Hello my dear students, in this particular lecture we will be discussing on a new module of automotive electrical systems, that is the starting system. Now the starting system has to be studied because what are the schematics of starting of an electric vehicle, and what are the motors that are used, what are the safety measures that are used, what are the precautions that are taken, what is the schematics, because the starting is very important, because the dynamics of a vehicle and the electrical phenomenon that occurs during starting, that is very important to study. So let us move to the module. So now the starting system, let us go to the each of the sections. Let me zoom this out. So the starting system includes the battery, the starter motor, solenoid, ignition switch, and in some cases a starter relay. So if we do a synopsis, so the starting system, it consists of battery, starter motor, solenoid, ignition switch, starter relay. So the battery is the heart of a starting system. So if we look the schematics of a battery, it is something like this. So it has one positive terminal and one negative terminal, right? So the positive terminal is connected to a wire which is connected to the load, and the negative terminal is connected to the other end of the load, right? So there is a switch. Let me just redraw this. There is a switch like this which is open, and when the switch is closed, current will flow through the battery. From where to where? From the positive terminal of the battery to the negative terminal of the battery, and let the current be denoted by IBATT, that means I battery. So what will be the value of the current? So let us say that the value of the voltage of the battery be V. So if it is equal to V and the resistance of the load, it is given by R, then the current of the battery IBATT will be given by V by R. So let us say that the value of V is 12 volt and the value of R is say 2 ohm, let us say, then it is 10 by 12 by 2, that is equal to 6 ohm. So this is the value of the current through the battery. So this is a schematic of the battery. Now after the battery, we have something called the starter motor. So let us draw the starter motor. The motor is symbolized in the last module. We have studied DC machines, and this is the symbol of a motor, which is symbolized by M. Right? So now it is a DC motor which has a armature RA, and there is a field which is RF. Right? And the voltage V, that should come from the motor. Sorry, the voltage V, that should come from the battery. Right? So what is the idea behind the motor? I will not elaborate it in very much detail, rather I would make the thing simple. So the motor has two objectives. It takes electrical energy as input, and it gives mechanical energy as output. Right? So if the mechanical energy is given as output, mechanical energy is denoted by tau and omega. These are the two parameters. So one is the torque and the other is the speed. This is the mechanical energy output. So the unit of the torque, it is given in Newton meter, and the speed omega, that is given by rad per second. So these are the two parameters which are our point of concern. So if we write the equation of a motor, what is the input V, and current will flow from the positive terminal. So this one is positive and the lower one is negative, and the current is given by, say, Im. So if we apply KVL or the Kirchhoff's voltage law, it is given by something like this. So V minus IMRF minus IMRA, and what is the back EMF? The back EMF is given by EB. The back EMF is given by EB. So if EB is the back EMF, So that will be equal to EB. Again, EB is equal to, I have already derived in my last lecture, it is equal to constant into omega into phi, right? And what about the torque? We will come to the torque later. And if we, this is equation 1, if we substitute the value of equation 2 in equation 1, you will be getting as k omega phi is equal to V minus IAR minus IMRA. So omega is equal to V minus, let us take Im common, it is RF plus RA divided by K. What is phi? Let us make it as K1. So more is the value of flux, more will be the value of phi. So it will be, just erase this part. So let us rewrite this thing. V minus, this is K1 and it will be IF. So it is V minus Im into RF plus RA by K1 IF. So this is known as the, this is what? This is known as the speed equation. Right? And there is also something called the torque equation. So I will write the torque equation. So the torque is given by a constant. Let us take it as K dash, because we have renamed it as K1, K, like that. So let this be K dash, that is equal to phi IA. Now the point is, if it is a series motor, then phi will be proportional to IF, that is for all types of motors. But since the field winding is in series with the armature, so the field current, which will be equal to the armature current, so this will be equal to IA. And let us substitute the value of phi over here. So torque is equal to K dash into IA square. Right? So the torque is proportional to the square of the armature current. And remember, a series motor is chosen above all the motors because since it is square of the armature current, so a DC motor has the ability to produce the highest torque. Right? So it has the ability to produce the highest torque. So these are the two things. One is the, this is known as the torque equation. So for any motors, two things are very important. One is the speed equation, and the other is number 2, torque equation. So these two things are very important points of concern in a DC motor. So next comes the solenoid. So as you can see over here, the solenoid is mounted on the starter motor. So what is a solenoid? So solenoid it is basically a motor in which we have ferromagnetic materials which is used to be excited with the help of field current. So when field current is passed through that ferromagnetic material, that particular ferromagnetic material exhibits magnetic property, and magnetic lines of force in form of magnetic flux will be emanated from that ferromagnetic material, and the trajectory will be, or the path will be, from North Pole to the South Pole. So let us draw that particular thing. So suppose, let us say, you have two ferromagnetic materials connected to a frame which is known as the rotor frame. So this is the rotor, and the inside of the rotor, this type of two protruding ferromagnetic material in form of poles, they are mounted. So now these two poles are connected in series such that when current flows, so suppose Vf is the field voltage that is given, and when current passes like this, what will happen when current passes? This will form the North Pole by right hand thumb rule. The direction of the flux phi will be from north pole to the south pole. Let us rename it as phi f. So it will originate from the north pole and end in the south pole. And this phi f is called field flux, whose unit is given by Weber, and IF is called the field current. And Vf is equal to the it is called the field voltage. So what will be the, let us erase this part. So what will be the value of field current? So IF will be equal to Vf divided by the Rf. So if the field voltage Vf, let us say it is 100 volt, and if Rf is equal to say 5 ohm, the field current IF is equal to 20 ampere. So now these parameters, that is the field voltage, field resistance, field current, so all these things depends on the size of the motor or the starter motor used in automotive vehicle. So there are several factors which decides the capacity or the design rather of this starter motor. So now the electrical parts which are mentioned over here is this battery, this solenoid which is mounted on a starter motor. So if we observe this, so you see, let us say that this is the negative terminal of the battery and this is the positive terminal. The negative terminal of the battery, you see, is grounded with the earth. So this part, it is connected to the ground, and you see, this is the other terminal is from the positive to the one part of the solenoid, right? Now what happens? The starter motor, now the starter motor, there is some safety precaution switch which is known as the neutral safety switch, and in series with the neutral safety switch you have the ignition switch. Now the battery is used to power the starter motor, and the starter motor it is connected to the neutral safety switch and the ignition switch, as we can see. So what is the purpose of the neutral safety switch? So the purpose of the neutral safety switch, it is also known as an inhibitor switch, which is included in the starting system circuit to prevent the vehicle from being started while in the gear. So this is the purpose of the neutral safety switch. So in a gear, if we see, there are 5 levels: 1, 2, 3, 4, 5 and R. So this is the gear of a normal automotive vehicle. So this is the gear, and R is the reverse gear, right? And when it is connected to none of this, it is not in gear and it is connected to the neutral. Generally, if this is your neutral stick, if you it is visible from the top, then it is connected like this. This is how 1, 2, 3, 4, 5 and R, they are located, and in the middle point, this particular point, that is the neutral position. So the starter motor will only be on when it is in the neutral position, and that is ensured by the neutral safety switch. And here you put your key, it is known as the ignition switch. So we will stop here for today. See you in the next lecture. Thank you.